This is a basic overview of the Digilent Nexys 2 FPGA board. This comes in two models, either the Spartan 3E 500 or the Spartan 3E 1200. It'll say on the side of the box which one you have. This one here is a 1200. Comes with a couple of items in the box. There's the actual board itself, which is right here, and then it comes with a mini USB to USB Type A connector. The mini USB connects onto the side of the board here, and that can also provide power for the board. Unlike some boards which require an AC connector or a battery connector, this one can do all three. It can do USB, battery, or AC connecting through right there. It has a jumper on here that allows you to select which one you use. Right now it's set on USB. You can change that jumper to either wall, AC, or battery, DC. This is the actual FPGA itself. There's a 50 megahertz oscillator right there. There's the reset button right here. The on-off switch right here for the board. This is a slot for another external oscillator. Then we have the 7-segment display here. 4 push buttons, 8 switches, and then a bank of 8 LEDs. That's the basic stuff. So let's get the board plugged in and get started. We're going to run through a basic VHDL program. We're going to bring it from start to finish. This will allow us to test our design suite installation as well as the board itself. So you'll want to have your board already plugged in. You'll want to have the Xilinx ISE design suite installed. We're using 12.4. You'll also want to download Adept too. This is available at the Digilent Inc. website, www.digilentinc.com. I'll include that in the comments on the video. So first, let's get started. We'll start up Design Suite. Okay, so we've got the Design Suite open. We're going to create a new project, File, New Project. We're going to call this one Test Project. Now you can put these wherever you'd like them. I just keep mine in a folder called FPGA because it helps me keep track of them. You can put them wherever you want to put them. You can also type in a description, and you can select here what your top level source type is going to be. We're going to select HDL because that's what we're going to use for this one. Click Next. Now here's the important part. This is where you need to know what kind of board you have. You'll go on ahead and select Spartan 3E. You'll select the 1200E, the X3S 1200E if that's the proper one for you. You may be using the 500E or something else. We're using the 1200E today, and the package that we've got is the FG320. So if you're using a Nexys 2, you're going to use the FG320 package, speed -5. We'll leave that where it's at. Typically, the default preferred language is Verilog. We're going to leave it. We're going to switch it to VHDL just because that's what I'm working with. And once we've got all that set, we can go on ahead and go to Next. It'll just give us an overview, project summary of everything that we entered in here, and we'll hit Finish. That'll create us a nice empty project here. So if we go over here to the hierarchy, we're going to right-click. We can add a new source. What we're going to add is a VHDL module, and it's important to have a standard naming scheme across your project because when you get into a large project with many hundreds of files or something like that, then you need to be able to find the right one quickly. So we'll call this one Test VHDL Source. And then we can add our ports in right here. We're going to have 2 in ports and 1 out port. First one's A, second one's B, third one's C, and that one's going to be our out port. Click Next, and it'll give us a summary again. Then we'll click Finish. Now the wizard created a lovely little file here for us. And so all we have to do at this point, instead of creating this entire thing, all we have to do is just punch in our code. Our code's only going to be one line, and we're just going to make C, A, and B. Alright, so then we'll save it. And the next thing we need to do, now that we've got our high-level design done, we need to add we need to link it to the board itself. So the way that we do that is using an implementation constraints file. It's also called a user constraints file. This will allow us to specify which pins from the FPGA are actually in use as inputs and outputs. So we'll call this file test UCF. It gives us another summary. We'll click Finish. It gives us just basically an empty file here. So the syntax for this is net, and then the name of our input or output, and then the location of our input or output. And we're going to connect this one to G18, which is switch 0 on our board. Input A. And then we'll add B and C in the same manner. Oh, don't forget your quotes. And we're going to make C an LED so that if C is true or 1, then it will light up a little LED above the switches for us. Okay, and that's all we have to do there. We save it. Double check our source file here. Okay, so now we have to go through the three phases here. We have to go through synthesis, implementation, and then generate our programming file. So what we can actually do is we can right click on there and tell it to run all, and it'll run through everything for us. You can see here it'll show us everything. It's going through the translation process now. Okay, it's mapping it to the board. Now it's running a place and route. Okay, now we're generating our actual bit file that we're going to use. Okay, now we've got all that done. With some boards, you can actually go in and you can control everything from the Xilinx Project Navigator. But with the Nexus 2 board, you need to use the Digilent software to program the FPGA itself. So you'll actually run the Adept software. Make sure that your board is plugged in and turned on so that it can be recognized by the device or by the software. So you can see here it's recognized our FPGA, XC3S 1200E. Now you can also program it to the PROM if you want it to remain in memory. But we don't. We're just going to run our we're just going to run it on the FPGA. So it'll lose it next time it comes back up. So we're going to go into our folder here, and we're going to go to our test project and find our bit file. So we grab that bit file, we tell it to open it. It's going to tell us that it's going to give us an error with it, or a warning. We're going to go on ahead and let it associate anyway. And then we tell it to program. It's going to give us the same warning. So the programming is now successful. Alright, we got our board all plugged in. We've got it turned on. We've got our power light there and our done light there. We've got it plugged in. We've got the program programmed onto the FPGA. So now all we should have to do is toggle our inputs, and we should get the expected outcome. So basically we should have switch 0 and switch 1 should be ANDed. So any combination of 0 and 1 shouldn't give us anything, but 1, 1 gives us a green light. So that means that our board's working properly. We've got our IDE set up properly, and everything looks good to go.